Assalamu alaikum. Hello, my dear students. How are you? I hope everything is well. My dear students, today, inshallah, we are going to start the next lesson, 5.3, the third topic in chapter integration. Integration using trig relationships. The first point here, we need to recall what we have studied before. One point in the differentiation. If we say let f of x equals tan x, okay, in the first semester we have studied how to differentiate the tan x, okay. It was f prime of x equals secant squared x, okay. So the derivative of tan x is secant squared x, okay. If we integrate now, you know the integration is the inverse of differentiation. Means if I start from here, okay, if I want to integrate secant squared x, so we can start here the first identity, the first formula. Today, the integral of secant squared x dx, okay, that will be tan x plus c, okay. So this is the first identity or the first formula, okay, and this one will be given in the formula sheet, but you should know, you should memorize it, okay. The integral of secant squared x equals tan x plus c. But if we have here a function of x, okay, so we can say the integral of secant squared ax, okay, function of x dx, okay. If here there's ax, you have to divide by this a, so it will be 1 over a tan the same function ax, okay, then plus c, okay. So you need to recognize, you need to know that if you have here ax, you should divide by 1a. Notice the difference between this and this. Here just 1x, okay. The constant here or the coefficient of x here is just 1. But if the coefficient is ax, okay, you have to divide by that a. So you say 1 over a tan ax plus c, or could be written as tan ax over a, okay, then plus c, okay. Type one more identity, but this identity it will be proved later, not now, next topics, okay. The integral of cosecant squared x dx, okay. The integral of cosecant squared x dx, this will be negative cotan or negative cotangent x plus c, okay. This one will be proved in the coming lessons, inshallah. The integral of cosecant squared x dx equals a negative cotangent x plus c, okay. What if we have ax here? The integral of cosecant squared 2x dx, okay. As we said before, if we have any ax, okay, if we have cosecant squared ax, not 2, any constant ax, it will be negative 1 over a, okay, cotangent x plus c, cotangent ax plus c, okay. So this for the first point here, okay. Now let's solve the first example here in this topic. Find the integral of 5 secant squared 0.2x plus 10. This is example 4 written in the book, the first example in this topic, okay. Here there is a coefficient of secant squared, there is 5, so this one could be written as, you can take this 5 outside the integral, so 5 the integral of secant squared the function or the quantity 0.2x plus 10, okay, dx, okay. So now this 5, okay, could be taken outside the integral sign, so 5 the integral of secant squared, okay, the same quantity 0.2x plus 10 dx, okay. We know what is the integral of secant squared. The integral of secant squared is just 10, okay. But here there is ax, so you need to divide by that a. So this 5 must be divided by 0.2, 10 the same quantity, 0.2x plus 10, then plus c. Okay, what is 5 over? Your answer should be in the simplest form. 5 over 0.2, if I multiply up and down by 10, so it will be 50 divided by 2, which is 25. So 25, 10, the same quantity, 0.2x plus 10, okay, then plus c, and this is the final answer for this question. Next one. Here, you know that the integral of sine x dx equals negative cosine x plus c. Okay, this is studied before. The integral of sine x equals a negative cosine x plus c. But what if we have question the integral of sine squared? See, this is sine, but here sine squared, sine power of 2, sine squared x dx. Okay, actually to solve this one, the integral of sine squared, okay, you need to recall one identity solved before, the cosine double angle. Okay, cosine double angle. See, cosine double angle, the cosine 2x. If you remember, we have studied here 3 identities for the cosine double angle. Okay, it's 1 minus 2 sine squared x. Okay, 2 cosine squared x minus 1 and cosine squared minus sine squared. Okay, type. Let's take one of them. Okay, which is 1 minus 2 sine squared x. This identity, it is very useful here to solve this question. Okay, because we need sine squared here. We need this sine squared. So we need to make this sine squared the subject. Okay, so just shift the minus 2 sine squared to the left hand side. It will be 2 sine squared x. I'm shifting this to the left hand side, equals 1 as it is, then minus cosine 2x. Okay, then divide all by 2 just to get rid of this 2. So it will be sine squared x equals 1 divided by 2 is just half, minus here minus 1 means minus 1 over 2 cosine 2x. Okay, this is what we need. Okay, we need what sine squared x equals half minus half cosine 2x. Half minus half cosine 2x. Okay, now let's take this value to plug in here. Okay, so instead of sine squared x dx could be written as the integral of half, the quantity half, minus half cosine 2x. Okay, dx. Now let's integrate. We have 2 terms here. The first term is half. The integral of half is, of course, half x. Any constant, its integral is that constant multiplied by x. So the integral of half is half x. Okay, minus what? Minus half. Okay, the integral of cosine 2x is sine 2x. But don't forget to divide that by what? By 2, because here we have ax. Okay, then plus c. The final answer, to simplify this answer, write half x as it is, minus, you know the integral shabab of cosine is sine. The integral of cosine x is sine x. Okay, but here cosine 2x, so the integral of cosine 2x is sine 2x, but don't forget to divide that by a, which is 2 here. Ax dividing by a. Okay, minus half and times this half also. 1 over 2 means half. It will be minus quarter sine 2x, the quantity 2x, then plus c. This is the final answer of this. So it's half x minus quarter sine 2x plus c. Here we just start the exercise 5.3a. The exercises given here in this topic. Okay, the first one is very simple. The integral of secant squared x, that will be what? Just tan. The integral of secant squared is tan x plus c. This is very easy. This is just a formula, and this formula will be given in the formula sheet. So this is very simple question. I think this will be not given in the final exam because it's very easy. Here, the integral of secant squared 2x, ax, okay? You should divide by this a, this 2. So we say 1 over 2. The integral of secant squared is tan, the same quantity, 2x, then plus c. And here, this one, question C, here secant squared, the quantity 2x minus 1 dx, again, this is ax, this is ax, so you should divide by a, which is 2, okay, then tan, the quantity 2x minus 1 plus c. Here show that the integral of cosine squared x dx equals half x plus quarter sine 2x plus c. We solve it like this here in the, I think, the beginning of this topic, but it was the integral of sine squared x. But this time, this is the integral of cosine squared x. Okay, so let's solve a here using, as I told you, the integral or the identity of cosine 2x. Okay, the cosine 2x, I told you there is 3 identities for cosine 2x. Okay, this time we need to use the 2 cosine squared x minus 1. Okay, so if we take this one, or if we take this one to the left to make it subject, so it will be 2 cosine squared x. So we can rearrange this identity to be written as 2 cosine squared x equals, if we shift the minus 1 to the left, it will be positive 1 plus cosine 2x. Just I'm rearranging this identity. So 2 cosine squared x as it is, okay? Minus 1 will be shifted to the other side. It will be positive 1 cosine 2x as it is. Okay? Then you should divide all by 2 to get rid of this 2. So we say cosine squared x equals half plus half cosine 2x. Okay? This is cosine 2 squared x, and this is what we need here. Okay? So we can say the integral of cosine squared x dx could be written as the integral, just plug in instead of cosine squared x here, we need to write it plus the integral of half plus half cosine 2x dx. Okay, so the integral of half is half x, as I mentioned before. Okay, plus what's the integral of cosine? As you know, the integral of cosine is just sine. Because of this 2, we have to divide by 2. So half dividing by 2, it will be quarter. Okay, sine 2x plus c. And this is what required here. See, the left-hand side has the integral of cosine squared x dx. The right-hand side is half x plus quarter sine 2x plus c. Okay, now we finished proving this question. For question B, okay, we need the integral of cosine squared 2x dx. Okay, so you need to compare between this question and this question. Here, cosine squared x, question A, but here cosine squared 2x. Okay, cosine squared what? 2x. So the difference here just x, but here double angle. So we can use the same answer here, but you need to double the angle, and don't forget to divide all by a, which is 2 here. Okay, so you need here to use this answer with doubling each x. So instead of x, we need to double x. So the answer here will be what? Half. Instead of x, it will be 2x plus quarter. Okay, sine. Instead of 2x, you need to double that, 4x. Okay, then plus c. And don't forget to divide everything by what? This a, by 2. Okay, so the final answer is, okay, by canceling here, half times 2, of course, it's 1. Okay, so the final answer will be just x divided by 2, which is half x, plus quarter divided by 2, it's 1/8. okay, sine 4x plus c. So this is the final answer of this, half x plus 8 sine 4x plus c. Okay, here we have limited integral, question 6. The integral from 0 to pi over 2, okay? So if we have limited here, don't write plus c. Don't write plus c here, because this is limited, okay? Sine x, the integral of sine x cosine x dx. Here we need to recall one identity also studied before in grade 11, the sine of double angle. The sine 2x equals 2 sine x cosine x. Okay, just compare between this and this. Here sine x cosine x, but here 2 sine x cosine x. Okay, so this one could be written as what? The integral from 0 to pi over 2. Okay, if I multiply this by 2, 2 sine x cosine x dx. And if I multiply here 2, I have to divide outside by 2, okay? Multiplying this by 2, so you should divide outside by 2. So this integral could be written as half the integral from 0 to pi over 2. You know that 2 sine x cosine x, this is sine double angle, sine 2x dx, okay? Now it's easy to integrate this one. So just half as it is. Write half as it is, okay? The integral of sine 2x is negative what? Cosine 2x. But because of this 2, you have to divide by 2, right? So it's negative half cosine 2x, okay? And don't say plus c here because of this limited, so we say 0 to pi over 2, okay? Half times negative half, that will be negative quarter, okay? So it's negative quarter because of half times negative half. It's negative quarter, and we should what? Plug in pi over 2. So it will be cosine 2x means 2 times pi over 2. That will be pi. Then minus, okay? Then again, we need to plug in 0, negative quarter minus negative quarter, okay? Cosine 2x means 2 times 0, which is what? 0, okay? Cosine pi, shabab, is negative 1. Negative 1 times negative quarter, that will be positive quarter, okay? Negative, negative, that will be positive. Quarter, cosine 0 is 1 times quarter is quarter. So quarter plus quarter, that will be half, and that is the final answer for this question. Question B, the integral from this one also is limited from 0 to pi over 8. Okay, right. This one, see, sine 2x cosine 2x dx. Okay, this one is very similar to this. But what is the difference? Here sine x, but here sine double, sine 2x. So if I use the same identity, sine 2x equal 2 sine x cosine x. If I multiply here by 2 and divide outside by 2, okay? So it will be half the integral of from 0 to pi over 8. Okay, 2 sine 2x cosine 2x. Okay, this is what? Sine 4x dx. Okay, sine 4x dx. Okay, here it was sine double angle, sine 2x. So if I double 2x here, it will be 4x. Okay, now let's integrate. So keep half as it is outside. Okay, and the integral of sine is negative, negative what? Negative cosine. Okay, and you should divide by ax. You should divide by a, which is quarter here. So negative quarter, cosine the same quantity for x. Okay, and you should write the limited here, 0 to pi over 8. Just multiply half times negative quarter. That will be negative 8. Cosine what? 4x. X here, you should plug in pi over 8. Means 4 times pi over 8. Minus, again, minus 8. Okay, cosine 4 times 0. Because x here is 0. Okay, so this one will be negative 8. Cosine, if we simplify 4 by 4 and 8, okay, it will be pi over 2 plus 8 plus because of negative negative, 8 cosine 0. Okay, so minus cosine pi over 2 here is 0. So this term or this quantity, full quantity, it will be 0 plus cosine 0 is 1 times 8 is 8. So final answer is 1 over 8 or 1/8. Okay, this is the final answer for this question. Okay, don't forget that cosine pi over 2 is 0. Cosine pi over 2, that will be 0. That's why this quantity full is 0. 0 times negative 1 over 8 is 0. Okay, cosine 0 is 1. 1 times 8 is 8. So final answer here is 1 over 8. Okay, type. Question 10a. Here we need to integrate the secant square to x plus 1. Okay, I think this one is very close to the question number 1. It's easy. Okay, you know the integral of secant squared is tan, but you need to divide by this a. So it will be 1 over 2 tan the quantity 2x plus 1, then plus c. This one, the integral of cosecant squared, the quantity 3x plus 2 dx, okay, the integral of cosecant squared is negative cotangent, but because of this 3, you have to divide by 3. So you say negative 1 over 3 cotangent, okay, the quantity 3x plus 2, then plus c. Okay, the integral of cosecant squared is negative cotangent. You have to divide by 3 because of ax here, 3x. Okay, that was the last question today. Thank you, everyone. See you next lesson.